Glad to meet you, dear participant. My name is Olena Melnik. I present the writing team from Uzhhorod National University. Igor Povkhan, Oksana Mulesa, me, Olena Melnik, and Vasil Morokhovich. The title of our research is The Modified Algorithm 3 Method in the Geological Data Classification Problem. Classification tree methods such as regression trees and logical and algorithmic classification tree structures are actively employed not only in solving theoretical problems within artificial intelligence, but also as tool for decision support and analysis of large data sets. Furthermore, these methods are employed in related practical fields such as economics, management, and geology. The processing of training sample continues to be an essential segment in the application of the decision tree concept. Currently available methods for processing training samples in the construction of recognition function are insufficient to achieve the necessary accuracy of recognizing systems and to manage their complexity during the development of information systems. This deficiency is not observed in recognition system construction methods, which rely on classification tree approaches. Consequently, a modified version of the algorithmic classification trees methods, especially the second type, has been selected for use in our research. Let us formalize problem statement. This study continues the series of works dedicated to the issues surrounding tree-like schemes for recognizing discrete objects. These works address the construction, usage, and optimization of logical tree structures. It is recognized that the resulting classification rule of scheme constructed by any method of branching algorithm has a tree-like logical structure. A logical tree consists of nodes organized into tiers and developed in a certain stage of tree construction process. A significant challenge arises in synthesizing recognizing trees, which are essentially represented as a tree of algorithms and ICT structure. Unlike existing methods, a distinctive feature of tree-based recognition system is that the importance of individual features or groups of features and algorithms is determined relative to a function that classifies objects into categories. A fundamental issue remains the generation of decision trees in cases of low information features. The ability of LCT and ICT structures to perform uninvariant branching for analyzing the influence of individual variables allow for interaction with variables of various types using predicates. In the case of ACT, corresponding autonomous classification and recognition algorithms. This concept of logical trees is actively utilized in data mining, where the ultimate goal is to synthesize a model that predicts the value of target variable based on a set of initial data at the system's input. Currently, in the implied domain, a significant number of methods and algorithms implement the conception of decision tree, classification trees, with two of them becoming particularly prevalent. Thus, as a principal idea, the methods and algorithms for branching feature selections, algorithm nodes, in ACT can be identified as an optimal approximation on an initial hypothesis set by a ranking series of classification algorithms, leading to the central issue, the problem of choosing an effective branch criterion, selection of nodes, attributes, features of discrete objects for logical tree schemes and algorithms for ACT. An important issue remains to qualitative assessment of individual discrete features their sets and fixed combinations, which enable the implementation of effective branching mechanism within the structure of a logical tree. It should be noted that important issue includes the convergence of the process of constructing classification trees by branching feature selection methods and the selection of a criterion to stop the tree synthesis processes. This practical aspect will be the focus of the current work dedicated to ACT structures. The following basic ACT scheme for synthesizing a tree of algorithm of the second type based on a branched selection of generalized features allow us to build ACT structures of arbitrary complexity and efficiently. The first method stage is initial selection and evaluation of independent classification algorithms. At the initial stage, it's necessary to select and evaluate the basic set of classification and recognition algorithms from the initial algorithm library. The final structural complexity of the algorithm tree can be controlled at this stage. The next is stage of synthesis of algorithm tree structure and generalized features. At this stage, the central task is to build a complete regular classification tree, fixed LCT structure, where the corresponding tiles of the structure contain the selected classification algorithms fixed at the first stage of constructing classification sets. The idea of the second stage of synthesis of the algorithm tree structure is the procedure for synthesizing a set of generalized features based on preselected sets of independent classification and recognition algorithms. At the end of the second stage, after the formation of a set of synthesized generalized features for a given application problem is completed, they are located in the corresponding nodes, tiers of the tree of algorithm of the second type. The structure of the tree of generalized features is constructed. At the final stage, the stage of checking the constructed structure of ACT, we need to check the constructed ACT model. For each element object of the test sample, the corresponding values are calculated. This value is calculated based on a set of previously constructed generalized features for each node of the corresponding tree level. The general block diagram of this method you can see on the screen. The experimental validation of the proposed second type algorithm tree construction scheme underscore its capability to tune the complexity and accuracy of the resultant classification tree model. The model comprises various autonomous classification algorithms, which during the modeling process evolve into a hierarchical structure of generalized features. The selection of an optimal models from the array of constructed ACTs for a specific task hinges on evaluating multiple parameters and the effectiveness of the model. An essential stage in this process involves identifying the most critical parameters of the model, such as the feature space size, the number of varieties, transitions, and algorithms. This step is critical for estimating the ACT's error relative to the input dataset, facilitation comparison, and aiding the selection of a specific ACT model from the predefined ensemble. The defining measure of the quality and efficiency of the constructor model, whether ACT or LCT, is determined by an overall integrated quality indicator, which formula you can see on the screen. The Orion software complex was developed at the Uzhhorod National University based on classification tree method to generate autonomous recognition systems. The algorithmic library of the system includes 18 recognition algorithms, the primary task of which the effectiveness of algorithm tree methods was tested, was the task of recognition geological data, the task of separating oil-bearing and water-bearing strata. The initial parameters of this applied problem of geological data classification are presented in Table 1. At the examination stage, the constructed classification system should effectively recognize objects of unknown classification relative to these two classes. Before starting work, the training sample was automatically checked for correctness. The system implements a retraining and error collection scheme in the classification tree. The effectiveness of the constructed ACT models was evaluated on a test sample of 267 objects. A fragment of the main results of above experiments constructed models are presented in the Table 2. The next table presents information of the classification model generation time, the total number of vertices, and elementary and generalized features on the basic hardware configuration. All constructed schemes of classification trees, structures of LCT and ACT, provided the necessary level of accuracy given by the task condition, speed, and complication of the RAM. You can see on the screen the result of our investigation. The developed models of classification trees have successfully met the requirements for quality and speed in geological data classification schemes while maintaining a compact structure. The set of independent classification algorithms selected for generated generalized feature groups also demonstrated their effectiveness within the scope of this applied problem. Furthermore, the composite ACT structures resulted in a relatively low number of classification errors in both the training and testing datasets. The first type ACT structure exhibited superior quality compared to the second type algorithm trees. This superiority is attributed to the more complex construction of the model, which requires longer generation times. The time difference is constructing the first type of LCT models, which includes a step-by-step assessment of feature informativeness, was nearly 34% greater than that on LCT. The proposed method for constructing ACT models of the second type enables the criterion of economical and efficient classification models which specified accuracy. The efficiency of classification tree models and the associated software have been confirmed through practical application. Looking ahead, future research could focus on the further development of ACT methods, including the introduction of new types and schemes of classification trees. Thank you for your attention. For more information, you can contact the authors via emails or contact address.